The purpose of this video is for me to show you how to derive equations regarding projectile motions. In any study of projectile motions, one would be required to actually know, among others of course, 4 basic things. The first thing is time to reach maximum height, or simply T. The second thing is total time of flight, or simply big T. The third thing is the maximum height attained. And last but not least is the range, or R, of the projectile. This is actually H. So what we are looking for here is a formula for T, a formula for big T, a formula for H, and a formula for R. Now many books would be telling you all these equations, but I'm going to take it one step further and I'm going to teach you guys how to derive these equations, because these equations are easily derived from the basic 4 equations of rectilinear kinematics. Okay, so let's do this slowly, one by one. And let me start with a sketch of projectile motion. So this is the y-axis, this is the x-axis, and let's assume that we launch an object at an angle of theta to the horizontal, and the object does a path that is described like this. This is called a projectile motion, and this here actually is called the path of trajectory. Now let's assume we launch this object at an angle theta to the horizontal with the initial velocity of v0. Then, from the basics of physics, where I taught you how to resolve vectors, since we know v is a vector, velocity is a vector, the x component of this velocity will be v0 cos theta, and the y component here will be v0 sin theta. Now the first thing we're going to find is, we're going to find the projectile's time to reach its maximum height, or simply T. So basically what I'm trying to do is, if we have an object here launched in this manner at time t equals to 0, how long would this object take to travel from here to its maximum height? What would the t here be then, when it's at its maximum height? So let's look at the properties here. One can easily deduce here that Vx has a value, Vy is 0. So by using one of the formulas of the rectilinear kinematic motion, V equals to U plus AT, since I am interested in the y component, we shall say Vy equals to Uy plus Ay times time. Vy is 0. So 0 equals to Uy is the initial component of the object in the y direction. So it's V0 sin theta plus Ay is negative g. Why is this the case? Because this object is undergoing free fall motion, right? The only thing that influences the motion of this object is gravity. So this would be negative g, since the object will decelerate upwards, and this is t. Therefore, you will get your first equation. T equals to V0 sin theta over g. Now this is a formula that you must not only know, but you also have to learn to know how to derive it. Okay, so the first formula, T equals to V naught sine theta over G. So let's just put that result up here somewhere. T equals to V naught sine theta over G. This is the first result. Okay, now let's go to the next part. The next part involves me finding the total time of flight. To find the total time of flight, total time of flight, I would think that this object would go up, reach its maximum height, and come down at the same period of time. Which means, if it takes 5 seconds to go from here to here, I would think that it would take 5 seconds to come back from here, back to its position here. Now this is simply because the only thing affecting this object is gravity. Therefore, if the total time of flight is t, then I can confidently say that t will equal to 2t. Therefore, t equals to 2v naught sine theta over g. And this is the second property of a projectile motion. So let's again write the result here. T equals to 2v naught sine theta over g. So the first t is the time taken to reach its maximum height. The second t is the total time of flight. Now let's go for the third property. I need a bit of space, so we'll just erase this off. Okay, the third property is actually, I want to find the maximum height. That means, what is this value here, h? How do I find h? How high did the object go? Okay, so let's start by using the formula v squared equals to u squared plus 2as. Since I'm interested again in the y component, let's analyze this in the y direction. So we'll get v squared y equals to u squared y plus 2ay as y. Now, as how I explained earlier, the value of vy here is 0, simply because the object is already at its maximum height. Therefore, 0 equals to v naught squared sine squared theta. If you remember correctly just now, this value here was v naught sine theta, and this value here was v naught cos theta. So we get 0 equals to v naught squared sine squared theta plus 2, ay is negative g, and sy is the displacement in the y direction. So final position, initial position, the answer is h. Therefore, h equals to v naught squared sine squared theta over 2g. And this is the third important result for a projectile motion. Again, let's write that down here. H equals to v naught squared sine squared theta over 2g. This is the third result. Now let's go for the last final result, or last final thing that we need to find for projectile motion. And that's actually the range. What is the range? The range is actually the horizontal distance that is achieved by the object while it undergoes a projectile motion. So range is normally symbolized by the letter capital R, and we can start by saying S equals to ut plus half at squared. Now since I'm analyzing things in the x direction, therefore I will say Sx equals to uxt plus half ax t squared. Now I've already explained to you all that in a projectile motion, even though the body moves in two dimensions, that means it moves in the x and in the y direction together, there is only a value for acceleration in the y direction, and that value is negative g. While acceleration in the x direction is always 0, because gravity does not pull you horizontally, gravity always pulls you vertically downwards. So, following the fact that ax equals to 0, this term here cancels off and becomes 0, which simplifies the equation to Sx is displacement in the x-axis. I shall substitute that with r. Ux is v0 cos theta times t. What is t? T is the time taken to get from here to this point, which, if you remember correctly, is actually the total time of flight. So let's substitute this into t. So we get 2v0 sine theta over g. Now this very long equation can be simply simplified like this: v0 squared 2 sine theta cos theta over g, which mathematically can be simplified further to v0 squared sine 2 theta over g. And there we have the fourth important result, that the range equals to v0 squared sine 2 theta over g. Okay, another important thing that we need to know about the range R is that one would always like to know what is the angle, what is the optimum angle of launch, so that the range that is attained can be maximum. That means, what should the value of theta be so that range is maximum? So if you look at the expression for range, then R equals to v0 squared sine 2 theta over g. Therefore R maximum is, if we assume v0 squared to be a constant, so this is a constant, that means I don't allow you to change your velocity, I only allow you to change your launching angle. If this is a constant and this is a constant, the only thing that this would depend on is sine 2 theta, is this. So for R to be a maximum, sine 2 theta must be maximum. And everyone knows that the maximum value of a sine curve is actually 1. So when sine 2 theta equals to 1, 2 theta equals to 90 degrees, therefore theta equals to 45 degrees. So when theta equals to 45 degrees, the range attained by the object will be at its maximum. And that maximum value is, take theta equals to 45 degrees, substitute inside this equation, this whole thing here will become 1. Therefore, the maximum value of range will be v0 squared over g. This is the fifth important result. Thank you.